This story unfolds in the world of flight innovation, where the hum of spinning propellers hides centuries of engineering secrets. For years, pilots wrestled with forces unseen but deeply felt, twisting torque and swirling airflows that tugged planes off course. But there is a solution: elegant and powerful contra-rotating propellers. These twin blades spin in opposite directions, balancing the forces and unlocking new levels of efficiency and control. Once reserved for military machines, their promise is now stirring excitement across the aviation and marine worlds alike. The problem with single propellers. At first glance, a single propeller mounted on the front of an airplane seems simple, just a spinning blade pushing the plane forward. But this simplicity hides complex challenges. When the propeller spins clockwise from the pilot's view, it creates a twisting force called torque. During takeoff, this torque pushes the plane's left wheel harder against the runway, increasing friction. As a result, the plane tends to veer left before even leaving the ground. Once in the air, another invisible force appears. The propeller's spinning blades create a swirling airflow or slipstream which wraps around the fuselage. This spiral pushes the plane sideways, especially at low speeds, making control more difficult. Skilled pilots can compensate using the rudder, but the effect is always present. These forces waste energy and add to the pilot's workload. Early engineers searched for ways to eliminate these problems. Their answer came by rethinking how propellers spin and interact with airflow, leading to the concept of contra-rotating propellers, a design that changes everything. To solve the twisting torque and swirling airflow problems, engineers developed an elegant idea using two propellers on the same shaft but spinning in opposite directions. These are known as contra-rotating propellers. One set of blades turns clockwise while the other spins counterclockwise. This opposition balances the forces that cause the plane to pull left or right. The secret lies in a clever gear system, often involving spur or planetary gears that allows the two propellers to rotate smoothly against each other on a single shaft. Imagine two dancers spinning perfectly in sync but moving opposite ways, creating harmony instead of chaos. This design not only stabilizes the aircraft, but also improves efficiency by reducing wasted energy from spiraling airflow. To better understand this, a three-dimensional printed model reveals how bevel gears connect the shafts, spinning the propellers in opposite directions in perfect timing. Once mainly used in military aircraft, contra-rotating propellers now show promise for broader use, offering more power and smoother flight. The true brilliance of contra-rotating propellers is in their mechanical design. Two propellers sit coaxially, one behind the other, spinning in opposite directions thanks to a smart gear arrangement. Bevel gears shaped like cones mesh together to reverse the rotation of the second propeller compared to the first. When one gear turns clockwise, the other spins counterclockwise, perfectly synchronizing the blades to avoid interference. This setup changes how air flows behind the propellers. Instead of swirling wildly, the air is straightened and re-energized by the second propeller, reducing wasted energy. Advanced computer models show even more complex gear combinations that maintain precise one-to-one rotation ratios for smooth contra-rotation. This harmony delivers greater thrust and fuel efficiency. It's especially useful in fast planes and electric aircraft, where every drop of power counts. By canceling torque and smoothing airflow, contra-rotating propellers improve performance while making aircraft easier to control. The aerodynamic benefits of contra-rotating propellers go far beyond mechanics. A single propeller, forces air backward in a swirling, spiraling pattern that wastes energy and causes twisting torque. But when two propellers spin in opposite directions, the second one cancels out that swirling effect. The airflow behind the blades becomes much straighter and, more efficient. This means less turbulence and more thrust from the same power. Studies show this can improve efficiency by 6 to 16% compared to traditional single propellers. This boost matters most at high speeds where smooth airflow can significantly save fuel or extend the range of electric planes. Contra-rotating designs also help aircraft that need more thrust, but are limited by propeller size restrictions. By packing more power into a smaller propeller diameter, these systems offer smarter solutions. Plus, the balanced forces reduce stress and improve stability, making planes easier to handle during takeoff and maneuvers. This combination of power and control makes contra-rotating propellers a remarkable advancement in aviation history. The idea of spinning two propellers in opposite directions dates back over a century. F.W. Lanchester patented a contra-rotating propeller design in 1907, and even earlier in 1837 a similar concept was introduced for ships. However, turning this concept into practical machines was no small feat. It wasn't until 1988 that a Japanese merchant ship was fitted with contra-rotating propellers, and trials revealed a promising 15% energy savings. Despite the potential, the technology remained mostly limited to military aircraft because of its complexity and cost. One rare passenger plane, the Tupolev Tu-114, featured these propellers and amazed the world with speeds over 540 miles per hour. Yet it was infamous for its extreme noise, up to 110 decibels, forcing passengers to shout to be heard. The noise resulted from chaotic air mixing behind the blades, a problem engineers have wrestled with for decades. Still, the promise of improved performance keeps pushing innovation forward. While contra-rotating propellers face real-world challenges, they thrive in the virtual world. The popular game War Thunder offers players a chance to experience these propellers firsthand. Every vehicle from vintage biplanes to modern jets is recreated with incredible detail, including authentic sounds and flight mechanics. One standout is the Seafire FR Mark 47, a plane equipped with contra-rotating propellers that deliver powerful thrust and precise control. Watching the blades spin in opposite directions on screen reveals the system's intricate dance, making complex engineering accessible and honestly, pretty exciting. War Thunder features over 2,500 vehicles from 10 nations, offering diverse gameplay modes, from casual arcade to intense simulators. Its passionate community creates custom vehicles and modifications, adding endless depth. Through this immersive experience, millions learn to appreciate the subtle art of contra-rotating propulsion, blending education with entertainment, and keeping this fascinating technology alive in hearts and minds worldwide. Despite the efficiency of contra-rotating propellers, their biggest drawback has been noise. The Tupolev Tu-114's loud roar wasn't accidental. It came from the intense mixing of airflow behind the blades. As the first propeller pushes air backward, it creates swirling vortices at the tips. When the second propeller meets this disturbed air, the vortices collide, producing chaotic turbulence. This turbulence causes loud noise and accelerates wear on the blades. Another issue is cavitation, especially in marine settings, where vapor bubbles form and collapse, creating shock waves that damage propellers and increase noise. These problems have limited the wider use of contra-rotating propellers despite their efficiency. To combat this, engineers explore designs like the propeller, which uses smooth, twisted blades to reduce tip vortices and noise. This approach promises quieter operation and better performance. Finding a balance between power, efficiency, and noise remains a key challenge in bringing contra-rotating propellers into everyday use. The future of contra-rotating propellers lies in combining them with advanced designs like the propeller, known for smooth, twisted blades that reduce noise and tip vortices. Innovators like Greg Sharrow are developing contra-rotating propellers for boats, offering improved fuel efficiency, greater maneuverability, and quieter operation. Videos from MIT showcase how these designs nearly eliminate cavitation and noise, making marine propulsion cleaner and more efficient. Yet, the mechanical complexity remains a challenge. Gearing systems for contra-rotation add cost, weight, and maintenance. Electric motors and hubless designs might simplify this, potentially transforming contra-rotating technology for both air and sea. Though still emerging, these hybrids hint at a future where power, efficiency, and quiet operation merge seamlessly. Contra-rotating propellers are no longer niche concepts, but a vibrant engineering frontier waiting for breakthroughs that could revolutionize propulsion across industries. This journey through contra-rotating propellers reveals a blend of old wisdom and modern innovation. From early patents to cutting-edge three-dimensional models and immersive gaming, these spinning marvels hold the key to more efficient, powerful, and balanced flight and marine travel. Though challenges like noise and complexity remain, fresh ideas and technologies are shaping their future. Whether on a ship, plane, or in a virtual cockpit, contra-rotating propellers continue to push the boundaries of engineering. Their story is far from over. The next revolution in propulsion might be just around the corner.